Hello, good evening. I am Vasumati working in St. Peter's Engineering College. Today I have taken the session for the second years ECE and AAA students for the subject Laplace transforms and numerical methods. So in this I have chosen the topic called Picard's method. So this method tells that whenever we choose the differential equation dy by dx is equal to f of xy with the initial condition y of x naught is equal to y naught. So this is the given condition for the first order differential equation, which we assume it as f of xy. With the initial condition y of x naught is equal to y naught. Then the solution is obtained by the following procedure. So here the first approximation is given by y1 is equal to y naught plus integral x naught to x f of x y naught dx, and y2 is equal to, based on the first approximation, y naught plus integral x naught to x f of x y1 dx, and y3 is equal to y naught plus integral x naught to x f of x y2 dx. So like this, based on the previous approximation, we give the present approximation. So based on this y1, y2, y3 formula, we can frame for nth successive approximation. So that nth iteration formula can be given by yn is equal to y naught plus integral x naught to x f of x y n minus 1 dx for different values of n greater than or equal to 1. So choosing this as a general formula, we can find out the various values of y for given x, which is known as Picard's iteration formula. Now let us see a few problems on this. Find the value of y for x is equal to 0.4 by Picard's method, given that dy by dx is equal to x square plus y square and y of 0 is equal to 0. Now let us choose the given function as f of xy is equal to x square plus y square and y of x naught is equal to y naught. That means x naught is 0 and y naught is 0. So the given equation dy by dx is equal to f of xy we have written in the procedure. So we write f of xy directly is equal to x square plus y square. Now writing the nth formula, yn is equal to y naught plus integral x naught to x f of x y n minus 1 dx. So here putting n is equal to 1, y1 is equal to y naught plus integral 0 to x f of x y naught. So for n is equal to 1 here, f of x y naught dx. So this gives 0 plus integral 0 to x f of x 0, y naught is equal to 0. So putting y is equal to 0 in the given function, x square plus 0, that is x square dx. So integral 0 to x square dx. So that gives x cube by 3. The same way in the nth iteration formula, putting n is equal to 2. So y2 is equal to y naught plus integral 0 to x f of x y1 dx. So in place of y naught, we now replace y1. So y naught is 0, 0 plus integral 0 to x f of x y1. y1 is the value we have obtained as x cube by 3. So in place of y1, substitute x cube by 3. Now what is the function? Now this is of the form f of xy. So the given function is x square plus y square. So in place of y, we have to substitute x cube by 3. So x square plus x cube by 3 whole square. So this is integral 0 to x square plus x power 6 by 9. So this gives x cube by 3 plus x power 7 by 63. So this is the second approximation. Now if we can move to the third approximation, but what happens is when we go for simplification in this procedure, the terms may be more difficult to simplify. So that's the reason we stop in this problem till only n is equal to 2. If the calculation is easier, you can go for one or two more approximations based on the given function f of xy. So in this, for substituting for n is equal to 2, we take as a approximative iteration, so that gives the value of y for given x. Now in the question this is also asked for x is equal to 0.4, what is the y value. So now taking this as a approximative value, substituting x is equal to 0.4, y is equal to 0.4 whole cube by 3 plus 0.4 whole power 7 by 63. So this gives the y value as 0.0214. So this is a value of y for given x. Now the second problem, solve dy by dx is equal to 2x minus y and at y of 1 is equal to 3 by Picard's method. So this is the function f of xy is equal to 2x minus y, and this is of the form y of x naught is equal to y naught. So x naught is equal to 1 and y naught is equal to 3. So this is a general formula. Again we take yn is equal to y naught plus integral x naught to x f of x y n minus 1 dx. So put n is equal to 1 in this. So we have y1 is equal to y naught plus integral x naught. In this case x naught is equal to 1. So we have integral 1 to x f of x y naught dx. So 3 plus here given y naught is equal to 3. So 3 plus integral 1 to x f of x and y is n minus 1, that means putting n is equal to 1 f of x y naught. So 3 plus integral 1 to x f of x 3. So y naught is equal to 3. So f of x 3 dx. So 3 plus integral 1 to x f of x3. Now this is f of xy where the function is 2x minus y. So in place of y substitute 3. So this is 3 plus integral 1 to x 2x minus 3 dx. So integrating this with respect to x, 3 plus x square minus 3x. So this gives the value x square minus 3x plus 5. So for n is equal to 1, this is the first approximation. The same way we calculate the second approximation for n is equal to 2. y2 is equal to, formula is the same. In place of y0 we replace with y1. So y0 plus integral 1 to x f of x y1 dx. So here 3 plus integral 1 to x f of x and y1 is x square minus 3x plus 5. So in place of y we replace with x square minus 3x plus 5. So here the function is 2x minus y. So 2x minus x square minus 3x plus 5. So this gives the value 3 plus 2x minus of minus 3x. So this becomes 2x plus 3x. So 5x minus x square minus 5. So 3 plus this integral value from 1 to x will be 5x square by 2 minus x cube by 3 minus 5x from 1 to x. So 3 plus, substituting the upper limit, that will be 5x square by 2 minus x cube by 3 minus 5x minus of the lower limit. So for lower limit x is equal to 1, this is the value 5 by 2 minus 1 by 3 minus 5. So this simplified value will be 5x square by 2 minus x cube by 3 minus 5x plus 35 by 6. The same way we calculate for n is equal to 3, because here the function is simple. F of x is y is equal to 2x minus y. We calculate for n is equal to 3 because we just have to substitute y value and integrate. So we can calculate n is equal to 3 easily. So we go for the third approximation. y3 is equal to y0 plus integral 1 to x f of x y2. This is as per the general formula what we have, and this is the value of y2. So substitute in place of y1, that is y2 f of x, and y2 is this value 5x square by 2 minus x cube by 3 minus 5x plus 35 by 6. So now again this is of the form f of xy, where y is equal to this value, but we have f of xy is equal to 2x minus y. So 2x minus of this value, so 5x square by 2 plus x cube minus of minus, so that will gives you this value. So this integration from 1 to x, so 7x minus 35 by 6 minus 5x square by 2 plus x cube by 3. So this integration with respect to x from 1 to x will be given as, substituting the upper limit will be x only, so the function will not change for upper limit. minus the lower limit for putting x is equal to 1. So this limit will give you 71 by 12 minus 35 by 6 into x plus 7x square by 2 minus 5x cube by 6 plus x power 4 by 12. Now this is the third approximation for this problem. We don't have anything to compute y for given x, only the approximations are asked. So this can be, third approximation can be considered as a concluding approximation for the given problem. Now see another problem here. Given that dy by dx is equal to 1 plus xy and y of 0 is equal to 1. Compute y of 0.1 and y of 0.2. So let us write again the function f of xy is equal to 1 plus xy, where x0 is 0 and y0 is 1. So this is a formula, yn is equal to y0 plus integral x0 to x f of xy n minus 1 dx. So putting x0 and y0 value, which is given as 0 and 1, we get an integral 0 to x f of x1 dx. So in place of 1, putting y0 is equal to 1, so 1 plus x dx. So that gives 1 plus x square by 2 from 0 to x. So we have lower limit 0, so the function will be only 1 plus x square by 2. Now based on this, we go for second approximation. y2 is equal to y0 plus integral 0 to x f of x y1 dx. So 1 plus integral 0 to x f of x, y1 will be this value 1 plus x square by 2. And now this is the y value, so we can, function is 1 plus xy, so 1 plus x into this value 1 plus x square by 2. So 1 plus x into x will be x square plus x cube by 2. So this under integration with respect to x will be x square by 2 plus x cube by 3 plus x power 4 by 8 from 0 to x. So which is 1 plus x square by 2 plus x cube by 3 plus x power 4 by 8. This is a value of second approximation we are getting. Now based on this, we calculate the third approximation, because it is again a simple function given. y3 is equal to 1 plus integral 0 to x f of x y2. So in place of y2, we replace the value 1 plus x square by 2 plus x cube by 3 plus x power 4 by 8. So substituting in the given function 1 plus xy. So x into y is this value. So 1 plus x square by 2 plus x cube by 3 plus x power 4 by 8, because this is a y value now, and which is of the form f of xy. So this step simplifying will give you as this as a integration from 0 to x, finally giving you the simplified value as 1 plus x square plus x cube plus x power 4 plus x power 5 plus x power 6. Now here this is the successive approximation. At the third approximation we stop here, because if this is the y value again in the next step, the integration may become little more complicated. So that's the reason we stop till the third approximation, because we have many terms here in place of y. So from this only we calculate y of 0.1 and 0.2. So in this, put x is equal to 0.1. So that gives the value here from 1.10534, and putting for x is equal to 0.2, y of 0.2 in the final third approximation gives you 1.22289. So here one point you have to remember, whenever your function is a simple function, you can go for more number of approximations based on y1, y2, whatever you have in your approximation values. If those approximation values are very big terms, you are getting many terms you are getting, and that substitution, if it may give a complicated value, you can minimize your approximations to a suitable number, and so that from which you can calculate the function of y for given x. So this is a method called Picard's method, and this method we cannot say it is suitable for n number of problems to substitute, because we don't have a particular rule where we have to stop the approximation, because that depends purely on the given function, right? Thank you.